In this video, we're going to look at Sarrus scheme, and this is a simple trick for finding what the determinant. So I want to find the determinant of a matrix. Say it's a matrix A. So this matrix should be a 3 by 3 matrix for our trick to work. So let's look at it. So let's say we have your A11, your A12, and your A13, and then we have your A21, your A22, and your A23, and then you have your A31, your A32, and your A33. So what we do is we take the first two rows, the first two columns of the matrix. So we have your A11, your A1, your A21, your A31. This is the first column, and then we go to the second column. So we have your A12, and then your A22, and your A32. And we just do a genius stuff. So we just take this one. It's not really genius. So we take this one, and then you take the next. So you take the ones that are in diagonals but form threes, from the one from A11, and then till this one. Okay, we're just forming threes. And then what we're going to be subtracting, okay, I'm just going to show you. This one is just what we're going to be adding. So you're going to have your A11 times your A12, your A22 times your A33. So it's this one times that one times that one. So, and then we add the second one. So we have your A12, your A23, and then your A31. Then we add the last one, which is your A13, your A21, and then your A32. And then now we're going to be subtracting. What are we going to be subtracting? So we're starting from this corner. So first you start from the top corner, and now you start from the bottom corner. And the bottom corner is what you're going to be subtracting. So we're going to have this one till the corner, and then subtracting this one as well, these three, and then this one as well. Okay. So we have what? A31, your A22, and what? And your A13. Then plus what? So this is what we are subtracting. So plus what? Your A32, the second one. Your A32 times your A23 times what? Your A11. Then we add what? The last one, which is your A33. Then times what? Your A21 times your A12. So this is what you're going to be subtracting. Now let's try and look at it in action. So let's make up a matrix. Say you have 1, 0, 2, and then we have 1, maybe 0, negative 1, 1, or maybe just 2 and 4. Let's say we have 1 and 2. So this is our matrix. So what we do is, okay, let me write this a little bit closer. So what we do is we take the first two row. So this is the first row. So we have 1 as 0 minus 1. And then what we take the second row. This is the second row. So we have 0, we have 2, and then we have 4. Just like we did above. So we have this from the top. And then we have that one. So we are forming 3s, and then the last one, which is a 3. So we have 1 times 2 times 2. Then we add what? This one, the second one, which is 0 times 1 times negative 1. And then the last one, we add what? 2 times 0 times 4. And then what we're going to be subtracting, we're going to be subtracting from the bottom corner till the top, bottom corner till the top, bottom, okay, not really bottom corner though. So till what? Till the top. So we have minus what? Negative 1 times 2 times 2. Okay, let me remove that bracket. So plus what? 4 times 1 times 1. 1 times 1. This is the second one. And then the third one is 2. 2 times 0 times 0. So what are we having? So we have this is equal to, remember that this is what the determinant of what of this metric. Say this metric was metric A. So this is metric A. It's not really determinant over there. So the determinant over here, determinant of A. So if this was A equals 2, and then but then now when we have this 2, you cannot really say that it's pure A. But then so we have equal to 1 times 2 times 2 is just 4. Then this is 0, and that is 0. Then 4 minus. So here we have negative 1 times 2 times 2, we have negative 4. Then 4 and times 1 is 4. So plus 4, and then that one is 0. That's 0. So you can see that the determinant is equal to 4. So that is what the determinant of A using what you Sarrus scheme. So that is how you use Sarrus scheme.